Thermal energy, temperature, and heat. Many times when you are describing the weather outside or you're describing food that you're preparing, you use such words as hot and cold to describe the temperature. When it's hot outside, you say the temperature is high. When you put a hot dish in the refrigerator, you're saying you're decreasing the temperature. So how are temperature and heat related? Well, we know that we're surrounded by matter, and matter is made up of tiny particles called atoms and molecules. We know that whether it's a solid, liquid, or gas, these particles are in constant motion, moving in all directions at different speeds. Well, because these particles are moving, they have kinetic energy, and the faster they move, the more kinetic energy these particles have. If we were able to look at those particles in hot and cold objects, we would see that the particles are actually moving faster in hot objects. Now let's recall back to our matter unit when we were talking about solids, liquids, and gases. Particles move faster and separate as temperature rises, and the separation of particles results in an expansion of the entire object, and this is known as thermal expansion. Thermal expansion is an increase in the size of a substance when the temperature is increased. This can be used to explain the contraction of objects as well. When the temperature of an object is lowered, particles slow down, the attraction between those particles increase, and the particles move together. The movement of these particles that go closer together result in an overall shrinkage of the object known as contraction. Now there is one exception to this rule, and that is water. And this is because water molecules orient themselves according to negative and positive charges. When they do this, empty spaces occur in the structure, and the empty spaces are actually larger in ice than they are in liquid water. Therefore, water expands when going from a liquid to a solid state, and you can see this when ice floats on the top of your glass or on the top of the lakes in winter. Now, when we're talking about units, especially SI units for temperature, they are measured in kelvins. However, during this course, we are probably going to use the more commonly used temperature scale, which is the Celsius scale. When measuring temperature, we're going to use either a thermometer, and it's either going to be a glass tube that is filled with colored alcohol, which expands with increasing heat to give the reading of the temperature, or you may use a digital thermometer that relies on the increase in electrical resistance with higher temperature to get a temperature reading. Now, when we were discussing particles in an object, we also need to talk about these particles' thermal energy. Now, thermal energy is the total kinetic and potential energy of all the particles in an object. Therefore, the thermal energy of an object increases when the average kinetic energy of its particles increase. So what does this mean? Well, of course it means that the thermal energy of an object increases as its temperature increases, and we need to see how this relationship all goes together. Let's recall back to our energy chapter when we were talking about potential and kinetic energy. If we have a ball on the ground and a ball sitting high on the edge of a cliff, we know that the Earth is exerting a more attractive gravitational force on the ball that is up on the cliff because it's separated from Earth's surface. The more the ball and the surface of the Earth are separated, the more gravitational potential energy the ball has. In the same way, atoms and particles exert attractive forces on each other and have increased potential energy when they are separated. So if I were to ask you what contains more thermal energy, liquid water at 100 degrees Celsius or steam at 100 degrees Celsius, what would you say? Well, since thermal energy is the sum of both kinetic and potential energy, then the steam, even though it's at the same temperature as the liquid water, has particles that are moving farther apart. Therefore, it's increasing its potential energy. And it would be steam that has the higher thermal energy, and you would definitely be able to find out this if you have ever been burned by steam before. It is hot. Even like when you open a dishwasher, right? You can feel that. So what we'd also like you to do right now is write down these two equations shown here. While the science community mostly uses Kelvin and Celsius to measure temperature, much of the United States uses Fahrenheit. So sometimes when you have readings, you will need to convert Fahrenheit to Celsius or Celsius to Fahrenheit. If you've ever held an ice cube or a snowball in your bare hand for any length of time, you know that they will start melting. Well, why is that occurring? That's right. The ice and snow are melting due to heat. But where is that heat coming from? Well, the heat is actually coming from your hand, and heat is thermal energy that flows from something at a higher temperature to something at a lower temperature. It is a form of energy, and it is measured in joules, the same energy or the same units that energy are measured in. Now, if you were to ask somebody, does the cold of the ice move into a person's hand, or does the heat from your hand move to the ice? Some people may think it's the ice freezing your hand because it feels cold when you hold it. However, it is important to remember that heat always flows from warmer to cooler materials. Now, all materials have what is called a specific heat, and you have experienced this if you've ever visited a beach and had to run across the super hot sand to get to the water, or maybe you ran across a hot blacktop like on a driveway to get to the grass. In both instances, even though the sun has been shining on each material the same amount of time, one absorbs heat more than the other. So for the example of the sand at the beach, compared to 1 kilogram of sand, the amount of heat that is needed to raise the temperature of 1 kilogram of water by 1 degree is about 6 times greater. So the ocean water at the beach would have to absorb 6 times as much heat as the sand to be at the same temperature. The amount of heat that is needed to raise the temperature of 1 kilogram of material by 1 degree Celsius is called its specific heat and is measured in joules per kilogram degree Celsius as shown on this table. Using specific heat of common materials, you can calculate the change in thermal energy when heat flows into or out of an object. If Q is the change in thermal energy and C is the specific heat, the change in thermal energy can be calculated using the following equation shown here. All right, let's take a break, and it's time for you to show what you know.